This video is about injective functions, also called one-to-one functions, surjective functions, which are also called onto functions, and bijective functions, which are both one-to-one and onto. A function f is called injective, or one-to-one, if it always sends different elements of A to different elements of B. In symbols, we can say the function f is one-to-one if for all x1, x2, and x2 in A, if x1 is not equal to x2, then f of x1 is not equal to f of x2. Or equivalently, we can say that f is injective if for all x1 and x2 in A, if f of x1 is equal to f of x2, then x1 had to equal x2 after all. So you can see that these two definitions are equivalent because the second one is simply the contrapositive of the first one. We say that a function f is surjective or onto if every element of B, the codomain, is the image of some element of A, the domain. In symbols, we can say that for all y in B, there exists an x in A such that f of x equals y. Or equivalently, we can say that the codomain of f, that's at B, is equal to the range of f, the set of all images of things in A. Finally, we say the function f is bijective if f is injective and surjective. Please pause the video for a moment and decide which of these functions, represented by these diagrams, are injective, surjective, and bijective. The first graph, at the top left, is both injective and surjective. It's injective because distinct elements in the domain get sent to distinct elements in the codomain. And it's surjective because everything in the codomain gets hit by something in the domain, so the codomain and the range are the same. Since this function is both injective and surjective, by definition, it's also bijective. This second function is injective, but not surjective, and so it's not bijective either. It's injective because distinct elements go to distinct elements, but it's not surjective because C is in the codomain but not in the range. The third graph here is surjective, but not injective. Every element of the codomain gets hit, but they're two distinct elements that go to the same element, so it's not injective. Of course, being not injective, it's not bijective either. Finally, this last function is not injective or surjective or bijective. It's not injective because 1 and 2 both go to the element D, and it's not surjective because A and B aren't in the range. What about the function from the integers to the integers given by f of x equals x squared? Pause the video for a moment and decide if it's injective, surjective, and bijective. As a function from the integers to the integers, this function is not injective because f of, say, -2, which is 4, is the same thing as f of 2. So they're two distinct integers that get sent to the same element of the codomain. It's not surjective because, for example, if you look at the number 5, 5 is in the codomain, it's an integer, but there's not exist an x in Z such that x squared equals 5. There's no integer who squares 5, and so 5 is not in the range of the function. Since f is not injective or surjective, it's definitely not bijective. Notice that the details of what the domain is and what the codomain is important in determining if the function is injective and surjective. For example, if I'd used a different domain of just the positive integers, my function would have been injective. For this next example, my domain and codomain are both real numbers that are non-zero, and my function is given by f of x equals 2 over x. Pause the video and decide if f is injective, surjective, and bijective. For this example, f is injective. Let's see why. Suppose x1 and x2 are in the domain. And suppose that f of x1 is equal to f of x2, i.e. 2 over x1 is equal to 2 over x2. By cross-multiplying, we can see that 2x2 is equal to 2x1, so that means that x2 is equal to x1. Therefore, the function is injective, because whenever we have two numbers in the domain whose image is the same, then those two numbers actually have to be the same themselves. This is one of the definitions of injectivity. F is also surjective for this example. Let's see why. For any y in the codomain, we can find an x in the domain such that f of x is equal to y. Let's see what that would mean. That would mean, since f of x is 2 over x, such that 2 over x is y. Well, to do that, we can just let x be 2 over y, because then f of x is f of 2 over y, which is, by definition of f, 2 over y, which is the same thing as 2 times y over 2, which is y. So this part right here was kind of like my scrap work, but this part right here is the explanation for why we know that f is surjective. For any y in the codomain, we can find an x in the domain. I'll make it clear that this number is actually a non-zero real number. We can find this x in the codomain such that f of x equals y. That's the definition of surjective. Well, since we've got a function that's surjective and injective, yes, it is bijective. In this video, we gave definitions for a function to be injective, or one-to-one, surjective, which is the same as onto, and bijective, which is both. And we gave some examples of functions that have those properties and functions that don't.